So today we're going to continue with some rules of exponents by doing powers of monomials. And that's our objective, is how do we raise monomials to powers? We're still working with the same essential question as to why is it helpful to write numbers in different ways. So today we're going to go right into this rule. So I'm going to come back to this an example to give you the rule, but let's just talk about, seeing it, drawn out basically. So here you've got a power, 6 raised to the 4th power, and then you're going to take that power and raise it to another power. So 6 to the 4th raised to the 5th, almost like a double exponent. So if you look over here, there's the 6 to the 4th, and there are 1, 2, 3, 4, 5 factors. Now you're going to remember our last rule said that if you had a common base, which we do, these all have the base number of 6, you write the base and you add the exponents. Remember that from the multiplication rule? So 4 plus 4 is 8, plus 4 is 12, plus 4 is 16, plus 4 is 20. So the result of raising 6 to the 4th to the 5th power is 6 to the 20th. And my question is, my goodness, could we have gotten there easier? Do you notice a relationship between 4 and 5 and the number 20? Sure, it's multiplied. So notice that the product of the original exponents, now product again means the answer of a multiplication. So the product, the answer of multiplying 4 times 5 is 20. So when you raise a power to another exponent, to a power, you multiply the exponents. Let's go back and look at this box on page 32. To find the power of a power, you multiply the exponents. So if you had 5 to the 2nd to the 3rd, you would write the 5 and multiply the 2 times 3, 5 to the 6th. And we could pick up our calculator and we could evaluate that further to simplify that if we chose to. Now, what if there's a variable? If you have a variable raised to an exponent, raised to another exponent, you write the base and multiply the exponents. So we have 3 rules now with exponents. So on page 32, here's an example. We have 8 to the 4th raised to the 3rd. So we write the base, and when you raise a power to a power, you multiply. 8 to the 12th is your final answer. If you have a variable raised to an exponent, so a power raised to a power, you write the exponent and multiply the exponent, 7 times 5, k to the 35th. So you would have k to the 7th 5 times, 5 of those. So that's where the 35 comes from. So here's an example, for you to try. So this one is probably no trouble. This one's no trouble. Let's just take a look at this one before you go any further. So here you're going to take the 3, raise it to the 2nd, take the 3 to the 2nd, raise it to the 3rd, and you're going to take that and raise it to the 2nd again. Let's see what you think about that one. I'm going to ask you to pause the video and see if you can do A, B, and C. Okay, now that you're back, we would write the 2, and since we're raising a power to a power, we multiply 5 times 2, and it's 2 to the 10th. In your calculator, if you take 2 and use your exponent button to the 10th, you would see 1,024. Here, we would write the W, and power to a power, we're going to multiply, and you would get W to the 24th, and there's nothing more we can do with that one. So here, if we take the 3 to the 2nd to the 6th, you would get 3 to the 6th. Now go again to the 2nd power, and then you would multiply again. So 3 to the 12th. 2 times 3 is 6, and then you have to do it again. Times 2 is 12, and if you put that in the calculator, holy cow, 531,441. So when you raise a power to a power, you write the base and multiply the exponents. Now, what if we put a number in there? Like we've been talking about, what if there's a coefficient that's being multiplied 6 times x to the second raised to the third power? Again, if we take a look here, we can kind of see it drawn out, and then we'll go back to the rule. So that 3a to the squared is going to multiply 1, 2, 3, 4 for 5 factors. So notice you've got 3 times 3 times 3 times 3 times 3, or 3 to the fifth. And you have a to the second times 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 a to the second. Write the common base, add the exponents, 2, 4, 6, 8, 10, right? So we have 3 to the fifth, which in our calculator would give us 243. And when you have a common base, you multiply the exponents. So our final answer is 243 a to the 10th. I'm going to tell you what the number one wrong mistake is instead of putting 243, they just write the 3. A student doesn't take the 3 and bring it to the fifth power. But if you look here, the entire group, 3a squared, needs to be raised to the fifth, which includes the 3. So he's going to get the exponent of 5, and the a to the second is going to get the exponent of 5. When finding the power of a power, do not add the exponents. That's a common mistake because you're used to the multiplication rule. I'm going to just back up to that purple box to find the power of a product. So you're finding a power, and in here is, you've got a coefficient, you've got a multiplication thing going on. You find the power of each factor and multiply. So if we take a look at this one, the 6 is going to get the exponent of 3. And the x squared is going to get the exponent of 3. Now, 6 to the third goes back to our exponent lesson, which is 6 times 6 times 6, not 18, right? Not 18. It's 6 to the third, which is 216. And then when you have a power raised to a power, you multiply the exponents, or x to the 6. So you kind of see it here that you've got a group being raised to an exponent. Everybody in the group is going to get the exponent. So the a is going to get the exponent times the variable b is going to get the exponent. So here's 2 examples done for you on page 33. So notice they're going to take the 4 and raise it to the 4th power, and the p to the 3rd and raise it to the 4th power. 4 to the 4th is not 16, it's 256. 4 caret to the 4th, and then multiply your exponents, you get p to the 12th. Down here, the -2 is going to be raised to the 5th. See it right here? And remember, we catch the negative in the gloves in the parentheses when we go in the calculator. The m to the 7th gets the 5th power, right? And the n to the 6th gets the 5th power. -2 to the 5th is -32. Multiply the 7 times 5 to get 35 for the exponent on the m. And multiply 6 times 5 and get n to the 30th. Okay, guys, your final chance here to try these. I think there's one word problem at the end, but I'll pause the video and see what you can do with D, E, and F. So in D, you would have had 8 to the 2nd power. He gets the squared, which is 64, 8 times 8. And b to the 9th to the 2nd would be b to the, and don't forget to multiply, 18. 6 is going to be raised to the 4th power. X to the 5th is going to be raised to the 4th power. And y to the 11th is going to be raised to the 4th power. So there's the 6 to the 4th. And then we're going to have x to the 20th, 5 times 4. And y to the 11 times 4. And then we could pick up our calculator and do 6 to the 4th, and we would get 1,296, x to the 20th, y to the 44th. This whole group is going to be raised to the 3rd. -5 to the 3rd is -125. W to the 2nd to the 3rd would be w to the 2 times 3, which is 6. And z to the 8th to the Third would be z to the 24th. So the last thing I want to end with is just here's an example, kind of a silly one again, but a magazine offers a special service to its subscribers. If they scan the square logo shown on a smartphone, they can receive special offers from a magazine. And for some reason, I don't know why, somebody wants to know the area of the logo. So if you notice, one side of the square is 7a to the 4th b, like that would ever happen, right? But anyway, there's one side. And to find the area of a square, you're going to take the side times the side. So you're going to square this. So see 7a to the 4th b, I took it right here, to the second power. So length times width, and they're both the same. 7 squared is 49. A to the 4th to the second is a to the 8th, 4 times 2. And notice the b is missing his exponent, so don't forget to slide the invisible 1 in there. It's b to the 1st to the 2nd, and you multiply and get b to the 2nd. So the area of the logo would be 49, a to the 8th, b to the 2nd, and whatever the units were here, which they didn't give us, it would be square units, because for area, the units are always squared. And a little saying to remember that is area, square area. So anyway, we've added a third rule to our exponent rules. The first one was the multiplication rule. When you're multiplying exponents, you multiply the numbers in front and you add the exponents. When you divide the numbers in front and subtract the exponents. And today we added, what about a power to a power? So you take the number in front and raise it to the power, and then you multiply the exponents. So 3 rules. We'll keep reviewing them and mixing them up as we go. But today it was all about powers to powers, guys. Have a great day.